Okay, so this video is meant for pre-calc. We have our Chapter 5 quest, finally, hopefully, on Thursday. Hopefully no more cold days in between now and then. So here's a very good 10-problem review. This will probably take about a half hour, so hopefully you really work hard at this and we get a good grade for this third quarter. Alright, so first, we're going to simplify this. So to simplify this expression here, we need to find a least common denominator. So our LCD, I'll put it right over here. And the LCD here is going to be the first denominator, 1 plus cosine of x. And the second denominator is completely different, 1 minus cosine of x. Alright? So we multiply each fraction by what it's missing, top and bottom. So this first fraction, top and bottom, 1 minus cosine x, top and bottom, 1 minus cosine x. The second fraction, 1 plus cosine x, top and bottom, 1 plus cosine x. Okay? So now what do we get? Well, when we multiply, what I like to do is just write it out, not multiply it out yet. So we have 1 times 1 minus cosine x. The plus sign comes up, plus 1 times 1 plus cosine x. And that'll all go over this denominator, this LCD, and I'm not going to multiply it out. 1 plus cosine x, 1 minus cosine x. Again, I want to see if things will cancel. So we need to simplify this top. So if you go ahead and distribute the 1s, it doesn't change anything. So it's 1 minus cosine x plus 1 plus cosine x. All over 1 plus cosine x, 1 minus cosine x. And in the top, the cosines cancel, and I get 1 plus 1, which is 2. And since the numerator just simplifies to 2, I'm going to go ahead and multiply out the denominator, because nothing's going to cancel, so let's multiply out this denominator. 1 times 1 is 1. The outer would be a negative cosine, the inner would be a positive cosine, they would cancel, and then cosine times negative cosine is negative cosine squared. And now this is an identity. I'll write it right down here below in orange. We know that the sine squared x plus the cosine squared x equals 1. So if I subtract cosine squared x from both sides, I get the sine squared x equals 1 minus the cosine squared x. And there is 1 minus cosine squared x. It is the sine squared x. So this is 2 over the sine squared x. And if you have a sine in the denominator, that is the same thing as a cosecant in the numerator. 2 cosecant squared, because the sine is squared x. So be careful when you're combining these fractions. They're toughies. 2. Verify this identity. Okay? So again, in this problem, it doesn't really matter what side I work with. I'm going to work with the right side here. Okay? And I'm going to say, hey, this these two terms in the parentheses share a sine squared. So let's factor out a sine squared. So when I pull out a sine squared, I get 1 minus sine squared left inside. The cosine x just remains the same. And now you see how this sine squared on the left side, here it is. So that sine squared is done. So now this must become a cosine cubed. Well, 1 minus sine squared. I'll do it down here. Again, sine squared x plus cosine squared x equals 1. To get 1 minus sine squared x, subtract sine squared x. Cosine squared x equals 1 minus sine squared x. So 1 minus sine squared x here, 1 minus sine squared x there, substitute. Cosine squared x. Sine squared x, cosine squared x, cosine x. And cosine squared and cosine multiply to get cosine cubed x. And there's the left side. Done. Alright. Okay, next one. Alright, so now we're going to find all solutions of this equation in the interval 0 to 2 pi. So here's a solving one. Now, when you see this question, you say to yourself, I have a secant and a tangent involved in one equation. I don't like that, so I need to do a substitution. Okay? So again, hopefully we know, or we use our cheat sheet, right? 1 plus tangent squared x equals secant squared x. That's one of our identities. So, in place of the tangent squared, if I subtract 1, in place of the tangent squared, I can put secant squared minus 1. If I subtract 1, I get tangent squared all alone. So here's a tangent squared, here's a tangent squared. We'll replace it with secant squared x. So I will do that right here. 2 secant squared x plus secant squared x minus 1 minus 3 equals 0. I will combine my like terms. These secant squared x, I have 2 and I have 1. That makes 3 secant squared x's. Minus 1 and minus 3 is minus 4. I will add 4 to both sides. 3 secant squared x equals 4. I will divide by 3. Secant squared x equals 4/3. And then I'm going to take the square root. But before I do so, I do not like secant. I want to change this into the reciprocal, and that would be cosine. And if I take the reciprocal of the left side, right, the reciprocal of secant is cosine, then I need to take the reciprocal of the right side. And 4/3 becomes 3/4. And now, in terms of cosine, square root, cosine of x equals plus or minus, I get the square root of 3 over the square root of 4, and that is the square root of 3 over 2. And this is the unit circle value, I should know these angles. Now, since the plus and the minus is there, I'm looking for angles in all 4 quadrants. Okay? So I'll draw my unit circle right here. If the cosine is radical 3 over 2, that means I go out farther than I go up. That's the 30-degree angle, or pi over 6. I am in the pi over 6 family. So the first quadrant angle is pi over 6. The second quadrant angle is 5 pi over 6. The third quadrant angle is 7 pi over 6. And the fourth quadrant angle is 11 pi over 6. And there's the 4 solutions to this question. Okay, so make sure if you see two different trig functions, if you can make them into one, that's a good thing to do. All right. Next one. Here we go. So a little word problem. It said a batted baseball leaves the bat at an angle theta with the horizontal and an initial velocity of 100 feet per second. The ball is caught by an outfielder 300 feet from home plate. You see the figure there. Find theta if the range r of a projectile is given by this formula. Okay? So we're going to use this formula here. R equals 1 over 32 v sub 0 squared sine of 2 theta. Okay? And the idea here is, let's plug in what we know. So we have a couple numbers. We have this 100 feet per second, and I'll circle, that's the v sub 0. And notice right here, r is 300. That's the distance away from where this ball initially took its velocity, or its approach from the bat. Okay? So I plug in 300 here. 1 over 32. V sub 0 is 100 squared. Sine of 2 theta. And again, my goal is to solve for theta. So the first thing I'll do is I'll try to get sine of 2 theta alone. Okay, so to do that, what I will do, and I'll just do this in the calculator, is to get rid of the 32, it's a 1 over 32, I'll multiply by 32. And then to get rid of this 100 squared, I'm going to divide by 100 squared. Okay? And what that'll do, that'll cancel the 32 and cancel the 100 squared and get my sine squared, or sine of 2 theta, all alone. So on the left side, I will multiply that out using my calculator. So we have 32 times 300 divided by 100 squared. And I get a nice round number of 0.96. Okay? And now, to find theta, 0.96 is not a unit circle value, so I will use inverse. If I use the inverse sign with this 0.96, I get what 2 theta is. Not just what theta is, but what 2 theta is. Notice I haven't touched the 2 yet. Remember, if you have a multiple angle kind of solving problem, you can wait until the end to take care of that. Okay? So, make sure you're in degree mode, because I want it in degrees. Inverse sine of 0.96. I get 73.7 for 2 theta. And now to find theta divided by 2, theta is 30, let's go just round to one decimal, 37 degrees. So that is the angle at which the ball took off for this situation to happen. Okay? So again, remember, if you're solving, if you have one trig function and it has a multiple angle, like a 2 theta or a theta over 3, something like that, remember to take care of that number in front of theta at the very end. At the very end. Okay. All right, next one. We're going to use a sum or difference formula to find sine, cosine, and tangent. And what I would like to find, I'm just going to find one of them, and the one that I would like to find in this problem is the tangent. Okay, let's find the tangent. All right. So I'm looking for the tangent of 13 pi over 12. And before I can do that, I need to find two angles that either add or subtract to get 13 pi over 12. Now, because 13 is a rather large number, it's not like a 1 or a 2 or a 3, I'm going to add. Start with your denominators of 12, and now ask yourself, what two numbers can make 13? And again, there's multiple options here, but I'm going to go with a 4 pi and a 9 pi. That gives me 13 pi. And now I will simplify this. I can divide both of these by 4 and get pi over 3. I can divide both of these by 3 and get 3 pi over 4. These two unit circle angles will give me 13 pi over 12. So what I will do is I will take the tangent of 13 pi over 12 as the tangent of the sum of pi over 3 plus 3 pi over 4. And now I'll use the formula, okay? And I'll do it right down here. Tangent of pi over 3 plus tangent of 3 pi over 4 all over 1 minus tangent of pi over 3 tangent of 3 pi over 4. And now it is our job to fill this in and simplify it. Okay, that's our job. So the first thing I need to do is I need to know what the tangent values are. Okay, so over here for pi over 3, that's up here. Pi over 3 has coordinates 1/2 radical 3 over 2. Remember that tangent is sine over cosine, y over x. So because this radical 3 is on top, it's going to stay on top, no rationalizing. Its tangent value will be radical 3. So the tangent of pi over 3 is radical 3. That is going to replace tangent of pi over 3. And again, hopefully in your unit circle you put the tangent values, right, if you're thinking ahead. And then for 3 pi over 4, I'm over here in the second quadrant where tangent is negative. And of course, because for the pi over 4 family, it is radical 2 over 2, radical 2 over 2, the tangent value is 1, but of course it's negative 1 in the second quadrant. So here are my two tangent values, radical 3 and negative 1. So I'll plug that in. So the tangent of pi over 3 is radical 3, plus the tangent of 3 pi over 4 is negative 1, all over 1 minus radical 3 times negative 1. And this simplifies to radical 3 minus 1 all over 1 plus radical 3. And now I need to rationalize. And to rationalize means get the radical at the bottom, multiply by its conjugate of 1 minus radical 3, do the same thing on the top, times 1 minus radical 3, and this is a big FOIL question. And nice things should happen. Okay, so let's see what the top becomes. Radical 3 times 1 is radical 3. Radical 3 times negative radical 3 is negative 3. Negative 1 times 1 is negative 1. Negative 1 times negative radical 3 is positive radical 3. And that's all over 1. Outer term is negative radical 3. Inner term is positive radical 3. They cancel. And then radical 3 times negative radical 3 is negative 3. So here I get 2 radical 3's minus 4 all over negative 2. And when I divide each of these by negative 2, I get negative radical 3 plus 2. And you can also have 2 plus negative radical 3, it doesn't matter. Or, I'm sorry, 2 minus negative radical 3. So that could be your answer, or 2 minus radical 3 also. Okay. And there you go. Okay. All right. Halfway done. Let's go back to the beginning here. Let's take a look at the next 5. All right. So here's one of those triangle problems. So here we go. We have given sine of u is this, cosine of v is that. Both u and v are in the third quadrant. And we want to find the cosine of u plus v. So my advice to start this problem off is expand this. Cosine of u plus v is cosine u cosine v minus sine u sine v. And then if I look here, I know what the sine of u is, and I know what the cosine of v is, but I do not know what the cosine of u or the sine of v is, so I need to find them. And to find them, I create a triangle. I create 2 triangles. Now, these are third quadrant triangles, so let's start with u. So here's my picture. There's my triangle. Third quadrant, there's u. Sine of u is negative 7 over 25. That is opposite over hypotenuse. So I must find this missing side, x, using Pythagorean theorem. X squared plus 7 squared is 25 squared. X squared plus 49 is 625. Subtract 49, x squared is, and we get 576. Square root, x is 24. There's your missing side. 24. So from this, this is u, remember, from this angle, I need the cosine of u. We're in the third quadrant where cosine is negative, so the cosine of u is going to be adjacent, negative 24 over hypotenuse 25. So now I have this. And now to find the sine of v, I set up a similar picture. In the third quadrant, there's my v. Cosine is 4/5, negative 4/5, because you're in the third quadrant. Again, we need to find this third side. Hopefully you know by now this is a 3, 4, 5 triangle. Again, in the third quadrant, sine is negative. We need the sine of v. That's going to be negative, opposite 3 over hypotenuse 5. And now I have my 4 things. Plug them in. Cosine of u, negative 24 over 25, times cosine of v, given to me, negative 4/5, minus sine of u, given to me, negative 7 over 25, times sine of v, what I found, negative 3/5. Multiply across. Negative times a negative is a positive. 24 times 4, I believe, is 96. 25 times 5 is 125. Negative, negative, negative stays negative. 7 times 3 is 21 over 125, and we subtract. It's 96 minus 21 is 75 over 125. And now, oh happy day, it simplifies. Divide by 25, divide by 25. This is 3/5. And there you go. And there's the cosine of u plus v in this problem. All right, next one. Verify this identity, okay? And notice we have a couple, some indifference formulas here. So we're definitely going to work with the left side here. Expand cosine of pi minus theta. That would be cosine of pi, cosine of theta plus sine of pi, sine of theta. So that's this guy, expanded. And now, there's a big plus sign in between them. So if there was a minus sign, I'd want to put this in parentheses and be careful. But because of the plus sign, I don't have to worry about it. Okay? And now we're going to expand that, the sine formula. Sine of pi over 2, cosine of theta, plus cosine of pi over 2, sine of theta. And now we have some values that we can plug in now. I know what the cosine of pi is. The cosine of pi is negative 1. Negative 1 times the cosine of theta plus. I know what the sine of pi is. It's 0. 0 times sine of theta plus. I know what the sine of pi over 2 is. It's 1 times cosine of theta plus. I know what the cosine of pi over 2 is. It's 0 times sine of theta. And now what do I get here? I get a negative cosine theta. This goes away. I get a positive cosine theta. And that goes away. 0 times sine. And what is negative cosine plus cosine? That's just 0. And 0 equals 0. There you go. So simple expansion. So remember, in an identity situation, expand that out. It's some indifference. Okay, next, we're going to find the solutions in the interval 0 to 2 pi. And we did a problem before with a 2 theta in the sine, but notice now there's two trig functions. One has a 2x and the other has an x. So now we need to take care of this sine of 2x. And I know how because I know my double angle formulas. The sine of 2x is 2 sine x cosine x. So I can substitute in for the sine of 2x, this 2 sine x cosine x. 2 sine x cosine x minus sine x equals 0. And now this is a situation where, hey, I have a common factor of sine x. Pull it out. Because I'm a little nervous that there's sine and cosine, but when I pull out this common factor, look what happens. 2 cosine x minus 1. When I factor it, each trig function has its own factor. We're good to go. Set each one equal to 0 now. And now, if the sine of x is 0, okay, I got to think about what angles give me a sine of 0. Well, the angles that give me a sine of 0 are the ones here and here, 0 and pi, because their y value is 0. So x is 0, x is pi. Over here, let's solve for cosine by adding 1 and then dividing by 2. And now I'm looking for angles that have a cosine of 1/2. And again, on my unit circle, a cosine of 1/2 means I go up farther than I go out. That means I'm part of the pi over 3 family. Cosine is positive in the first and fourth quadrant. So my x values are pi over 3, and the fourth quadrant, 5 pi over 3. And there are my solutions to this problem. Okay. So again, if the sine of 2x was all by itself, solve that for 2x and then divide by 2 in the very end. But because the 2x and the x is in the same problem, different types of angles, you need to use a substitution. Okay. Just be aware of that. All right, 2 more to go. Number 9. We are going to use a double angle formula, and we're going to go ahead and find this double angle formula. We're going to find cosine of 2 theta. Okay, so just the cosine, this one. Cosine of 2u. So cosine of 2u is very interesting because it has 3 forms, right? So I'll write all 3 down. So it could be the 2 cosine squared, we'll use u because it is u, minus 1. It could be the 1 minus 2 sine squared u, or I believe it can be cosine squared u minus sine squared u. Let me double check that. Yes, cosine squared u minus sine squared u. So we can use any one of these forms to solve this problem. Now we are given this. Tangent of u is 3/4. That doesn't really help me because none of these involve a tangent of u. But notice what else they give me. 0 to pi over 2. This is quadrant 1. They give me enough information to create a triangle. This is a first quadrant triangle. Here is u. The tangent is opposite 3 over adjacent 4. Again, hopefully you know by now this is a 3, 4, 5 triangle. You need to find that third side. You can use Pythagorean theorem. And now you have choice. Would you like to do one that involves cosine, that involves sine, or involves cosine and sine? I would say do not use this bottom one because that's more than you want to work with. So choose one. I don't care which one you choose. I'm just going to choose the top one, right? So the cosine of u in this picture is 4/5. Okay? That's adjacent hypotenuse. So now I'm going to use this formula. 2 times 4/5 squared minus 1. That is 2 times 16 over 25 minus 1. That is 32 over 25 minus, and now make this one anything over itself, 25 over 25. 32 minus 25, that's a 25, not a 35, sorry. I'll undo that. Yeah. Okay, so that's a 25 over 25. So 32 minus 25 is 7 over 25. And there's your cosine of 2 theta value, or 2u value. Okay? So again, never do I care what the angle measure is. I don't care what u is, right? I just want to find these other trig values, given one trig value. So a lot of times it involves a triangle, especially when they give you this this interval for the angle. Okay. All right, last problem here. We want to find the sine, cosine, and tangent of this angle, and we want to use one of the half angle formulas. Okay, and we're actually going to go here and find cosine again. Okay, so we're going to find cosine. So I'm looking for the cosine of 112 degrees and 30 minutes. Well, if you remember how to do this, minutes, you divide by 60 to get the angles. So in your calculator, you would do 112 plus 30 divided by 60. Sorry, 30 divided by 60. And this would give you the decimal angle. And again, hopefully you know 30 out of 60 is a half. So this is a 112.5 degree angle. Do not worry about minutes and seconds on your quest, okay? It's fine. So now that is definitely not a unit circle angle, but maybe there's an angle that if I take half of it, I do get this 112.5 degree angle. And there is one. 225 divided by 2. If I take 225 and I divide by 2, I get 112.5. That's what I want, right? So now I use the half angle formula for cosine, which says plus or minus the square root of 1 plus cosine of u, or cosine of theta, whatever you want to call it, all over 2. And again, this is in a square root, right? It's in a square root. So 1 plus cosine of, and I'll use theta, all over 2. Now, to determine the sine of this, we have to figure out what quadrant 112.5 is. And 112.5 is in quadrant 2. In quadrant 2, your cosine is negative. So you're going to keep the negative in this problem. So we are looking at the negative square root of 1 plus, and now up here I really should not put theta, I should put what theta is. Theta is this top angle 225. And I should look at the unit circle, telling myself 225 is right here in the third quadrant, and it is part of the pi over 4 family. Okay? Pi over 4. Again, if you have your unit circle, have degrees and radians there. And if I'm looking for the cosine in the third quadrant, it's negative, and that's radical 2 over 2. So we have 1 plus the square root, or negative, opposite, sorry, negative square root of 2 over 2, all over 2. Alright, so now what I will do is I will simplify this, right? So I have a negative on the outside, square root. I'm going to turn this 1 into 2 over 2, so it will combine. Plus a negative is a minus, radical 2 over 2, and that's still all over 2. So now the top is now 2 minus the square root of 2 over 2, all over 2. And now I'm going to scroll this down, and we're going to write it side to side. So I'll put the square root in a second. 2 minus square root of 2, all over 2. And instead of dividing by 2 over 1, I'm going to multiply by the reciprocal, 1/2. And there's my negative square root. So this becomes negative square root. The top remains the same, 2 minus the square root of 2, but the bottom becomes a 4. And now when I break this apart, I get the square root of 2 minus radical 2 on top over the square root of 4, and of course the square root of 4 simplifies. So your final answer is negative square root of 2 minus radical 2 in the top all over 2. Square root of 4 is 2. And there's the answer. And again, what's nice is you could check this in the calculator, right? You could do, what is the cosine in degree mode of 112.5? It's some negative 0.38, okay? So this actually equals, I just did my calculator, this actually equals negative 0.38. So now I better hope if I can plug this in right, now that's a challenge because of parentheses and all that stuff, negative square root of 2 minus square root of 2. And now notice I'm going to put a parenthesis for the inside square root and a parenthesis for the outside square root. And again, your calculator might be different. All divided by 2. I get the same thing. This also equals negative 0.38. So you know you're right. Okay, you know you're right. Alright, so this is a very good comprehensive review. If you can do all of these problems without your notes, without anything but your brain and your cheat sheet, life is very good for you. You should be fine. Happy studying, and we'll see you on Thursday.